Now, topic modeling is used to discover hidden semantic patterns in the text corpus. Like, it is used to check what kind of patterns appear in the document, and then it helps us to identify the topics in those documents. So here we are going to make use of 5 techniques: LSA, LDA, NMF, PCA and ICA. So consider, if I have these various documents, document 1 tells that a whopping 96.5% of water on earth is in our oceans, covering 71% of the surface of our planet. Document tells that 1/3 of your life is spent sleeping. Sleeping 7 to 9 hours each night would help the body to heal itself. Document 3 tells a newborn baby 78% water. Document 4, while still in high school, a student went 26.4 hours without sleep. Document 5 tells that we experience water in all 3 states: solid, ice, liquid water, and gas water vapor. So now you can see that document 2, 4 talk about sleeping, and document 1, 3, 5 talk something about water. So here we create a corpus of these 5 documents, and then we download the needed packages. We clean all the documents, that is, we convert them into lowercase, remove all the stop words, and also lematize the words that are there. Now, for the first one is LSI model. LSA model. Now this is in the Gensim.models class. Here I specify the document term matrix, that is the here from the clean corpus I create a dictionary, that is here I am trying to create a document term matrix. Maybe I can demonstrate this document term matrix. See, this is my entire document term matrix. For every document in the corpus, here it is converting the document to bag of words, and here I get my, see, this is my first, the second one, and so on. I'm having the 5 documents. So this is my bag of words document term matrix. And then on that document term matrix, I apply the LSA model, and I'm looking for 3 topics. And here I also specify the dictionary. Now dictionary will have all the words that are there. Let me also demonstrate dictionary. Okay, this is a dictionary object, and it has to be viewed in a different way. I pass the dictionary and the document term matrix, and I'm looking for 3 topics, and here I ask the model to print 3 topics and the 3 words in each. So see, in the first document I'm looking for water, percent and rain. In the second document I'm looking for sleeping, hour and still, and in the third document I'm looking for, and for the third topic I'm looking for water, rain and planet. So first of all, we get the topic distribution for each of the document here. And now we have to display what is the topic distribution for each of the documents. See, for document 0 and for the topic 0, it is having a better score, 5.9267. Topic 1 is, that is, it is not at all belonging to topic 1. Topic 2, yes, it is, no, it is not at all belonging to topic 2. Whereas document 1 is more belonging to topic 1. And so on. This is my information about what amount of information is available, or what is the score for each document and the topic. I can get to know that. So for getting the topic distribution for each of the document, I make use of LSA for every document in the document term matrix, and then using enumerate, I give the document number for every document and for every topic distribution that is there. The loop is run. So in topic distribution, I will get the topic and what is the contribution, that number. Again using the same thing, I choose whatever is the max contribution, that is whatever is the max by contribution, I choose that becomes my dominant topic, and then I give the result that document 0 is most related to topic 0, document 1 is most related to topic 1, document 2 to 0, document 3 to 1, document 4 is related to whatever is the max contribution. So this is one of the model. The next one is LDA. Now under LDA model, I pass the document term matrix. The number of topics that I'm looking for is 3, and the dictionary. Now this is another model, works on different things. Now here this makes use of sand, great and sleep, water, percent and planet, and water, sleeping and body. These 3 belong to different documents. So same things here, same code here, same code, but here as we can see, document 0 belongs to topic 1, document 1 and 2 belongs to topic 2, document 3 belongs to topic 0, document 4 belongs to topic 1. The next one is NMF, which is non-negative matrix factorization. Here first of all we apply TF-IDF. Now this NMF techniques works on TF-IDF. So first of all we make use of TF-IDF here. And I'm looking for 2 topics here. I give the TF-IDF vector, which is applied on my clean corpus only, and I also pass the number of topics, and then after that now topic 1 includes these various terms: water, percent, rain, planet, experience, and topic 2 includes sleeping, sleep, hours, 10th, went. So these are the various words that we get in the top 5 words that we get in each of the topic. These are the top 5 words. So if it finds these words, it is going to judge whether it belongs to topic 1 or topic 2. The next is PCA. Now PCA and fast ICA. Now PCA, I can specify how many components am I looking for, and then again it is going to make use of TF IDF only. Now under PCA, it is applied on the TF-IDF vector, and I can enumerate these PCA components. Let us see what is there in the PCA component. So we have two components, component 1 and component 2. Water, percent, planet, rain and ice will belong to one component. Sleeping, help, spent, night, immune will belong to component 2. And depending upon the words, the documents will be classified into belonging to component 1 or component 2. So these are the top 5 words that are there. So here in each of the component we get top indices. That is, we take, that is, first of all we sort them in their we sort them in their order of increasing importance, and then we take the last five words, and then for those indices we also get the top words, and then we print the top words that are there. Similarly, ICA can also be applied. Again, ICA is another technique. And this has given me a slightly different output here. This is learn, life, immune, and here this is spent, night, immune. So some kind of different output is there. So this is about we can specify here how many topics do I want and what are the documents which will belong to topic 1, or which are the which document will belong to topic 2 or topic 3, or if I can have more number of topics depending upon the documents that is there. So it is internally looking at the document, and depending upon the word distribution, it is checking on what document should belong to what topic.